Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome back to the 8th Geoinformation Science Symposium 2023. For today's event, we will have two sessions. We have our plenary session in the first, and then in the afternoon, we will have a parallel session. For the plenary session, we will have our three distinguished keynote speakers, Professor Dr. Menno Jan Krak from University of Twente, Netherlands, Dr. Ariel C. Blanco from Philippine Space Agency, and Dr. Yuichi Sakai from Utsunomiya University, Japan. And for this plenary session, it will be moderated by Dr. Sandi Budi Wibowo, SPMSG. Dr. Sandi Budi Wibowo, the time and place is yours.
Good morning, ladies and gentlemen. Thank you very much for joining this session. I would like to introduce myself first before starting this session. My name is Dr. Sandi Budi Wibowo from Faculty of Geography, Universitas Gadjah Mada. Here I will be act as moderator for this session, and I would like to introduce you to all of you our keynote speakers. The first keynote speakers will be Prof. Menno Jan Krak from University of Twente, the Netherlands, and then the second speakers will be Dr. Yuichi Sakai, our close colleague from University of Utsunomiya University in Japan. He is already online, I guess, from Zoom meeting. And then the third speaker will be Dr. Ariel Blanco from Philippines Space Agency. I would like to invite all of our keynote speaker to here and then to deliver the presentation. Please come here. Please have a seat. So before wait a minute, I will prepare the CV first. Well, before starting the first keynote speaker, I would like to introduce Prof. Menno Jan Krak by regarding his outstanding CV. Prof. Menno Jan Krak is president of the International Cartographic Association from 2015 and 2019, is that right? And then he wrote more than 200 publications on cartography and GIS. His most visible publications are books on aspect of cartography, visualization of geospatial data, and then web cartography, developments and prospect, and then exploring geovisualization, edit with text and make Echern, published by Elsevier. So Prof. Menno Jan Krak will deliver a presentation on maps, challenges of mapping SDGs indicator data. Please welcome Prof. Menno Jan Krak. You have 35 minutes of presentation, and then it will be followed by 5 minutes or 10 minutes of question and answer session.
Okay, thank you very much. Good morning, ladies and gentlemen. It's a great pleasure to be here, and they told me if I push this button, something magic will happen, but I'm not sure. I'd like to see my presentation, please. Okay. I think the angle is wrong for the. So I will ask them next, and then those gentlemen cannot fall asleep today. Okay, please, next, please. Yes, thank you. So my idea is to take you on an adventure of writing a book on maps, of course, and that's a project which we've done together with the United Nations And we are some people from the International Cartographic Association. So it was my project when I was president of this international society. Next, please. So first I will explain a little bit about this book, and then we will address some dilemmas we have as cartographers if we want to present the SDG data. And of course, if you are the map user, you also have your dilemmas, as I will show you. So those three topics I will try to address during this presentation. Next, please. Okay, the book itself is available to all of you. It's free. It's downloadable. At the end, there will be the URL will be in big font, so you can see it and make a picture or copy it. You can download the book for free. At the moment, it's available in English and in French and Arabic. And some other translations are in the process of being done. We did this because today, if you think of science, it's all about open science. It's all about providing data for free, software for free. And in our case, we thought, okay, we will provide educational materials for free. So that's this textbook on cartography. And yeah, that means that some people said, you're going to talk about your book? You want to make money? No, there is no money involved. It's all for free, it's all voluntary. It's trying to help people who would like to monitor their country and who would like to get a spatial overview of the SDGs. Next, please. So we set up the book in a specific way, so there are all kind of topics, and each topic has 2 pages. And on the page you find illustrations, maps of course, and you find text describing all these, that particular topic, as well as keywords, which then again come back in a glossary. So next, please. There are 4 major sections. I'll go into detail to show you some examples. I will not only go through the book and tell you things, I will also share with you the experience we had in making the book. Working with an organization like the United Nations is not that easy. Lots of politics are involved. I would like to share this because for me they were a fascinating experience. So first we will explain, of course, a little bit about the SDGs, then about map design, followed by the map types we have available, and then of course where are we using these maps. Next, please. So again, the data we had available were from the UN. So every country has to deliver the data to the UN on all the SDG indicators. And what we try to do, if you need to make maps, of course you need spatial information, so you need coordinates, so to say. And the location is always a country, because for each of these indicators, I come back to what an indicator is in a moment, every country provides one number. And so you can only make a map of the world or regions where you can compare countries with each other. Then of course next to the location, this number is related to an indicator, which is the attribute, and is valid at a certain time. And when we worked with these data, it appeared that not all countries deliver these numbers. They are not always as trustworthy as you can think, so I'll come back to some of these issues. So actually it's just as you would work on your project, probably you struggle with data. You struggle with processing the data, and at the end you struggle with the visualization of this data. Well, working on the illustrations of the book, because we wanted to make this book such that every illustration was based on real SDG data. And that made our life difficult. Next, please. Then of course, if you go through map design, cartographers have a certain workflow, so to say, a way how they process the data, which is indicated by this circle on the left. And then on the right, there's a kind of approach that, depending on for whom you are making the map, you will design it in a certain way. And for instance, this world map is about the availability of clean water, and it was meant for children. So instead of a geometric symbol, we took a bottle, and the more water is in the bottle, the better the water quality. So that type of considerations. Next, please. Okay, about these SDGs. So there are 17 SDGs, and you will be aware of this, I hope. And each of the SDGs has certain targets. And every target has indicators. And these indicators are at the end the lowest number, so to say, which we can map. And what you see here is on the horizontal line, in the center you see the goals with the color band, so that they have each their colors selected by the UN. And then on the horizontal line for each of these goals, you see the targets. And if they are stacked on top of each other, there are multiple indicators for each target. At the end, there are about 230 different indicators. Only in the top part of the diagram, the dark blue ones, they are mappable. They are related to a spatial thing, so you can map them. And not only this, but also the dark blue ones are the only ones. I said it wrong. I start again. The dark blue ones are the ones on which all the countries agree. So, because if you would go to the database of the UN and you go to a particular target, you might find 10 pages of deliberations on how do we get this number. So imagine you want to say something about forest, then you get into the problem of what's a forest. And in some countries, a forest is like a tropical forest, where you almost cannot enter because it's so thick growth. In some other countries, maybe there is one tree every square meter, of every square kilometer, and they still call it a forest. So how does that work? Now, and that's for all these indicators. And so the dark blue they agree upon, and the light blue they are still deliberating. Then at the bottom part of the diagram, we have indicated the nature of this number. It can be an absolute number, but it could also be a percentage, the percentage of forest cover in a country. So there are different types of data qualities, and that's important to know because that decides on how you can map it. Next, please. Next, please. Yeah. Okay, so here you can see an example of the map types available and discussed in the book, and also the typical diagrams which we have. And of course, the most interesting part is if you combine maps and diagrams, and if it will be interactive. Because then you can query it, you can explore. Of course, in the book on paper, you cannot do that. So it's only described and not done. So next, please. Because, okay, you can use your maps on a phone, on a big screen, or in a book. And each of these different media where you present your maps, that requires a different approach in the design. Next, please. Okay, so the interesting thing is that for this book, we created over 94 new maps. And you can see the other numbers, many schematic maps, many diagrams, and many. So it was quite an endeavor to create this. And we created this with 5 people. And next, please. But if you would look at the book, many things are not there. So for instance, at this conference, we talk a lot about remote sensing. In this book, no remote sensing. Because again, the indicators are related to numbers for an enumeration district for a country, and for a polygon, so to say. And remote sensing data is of a different nature, so that's not there. It's also not about topographic maps. It's also not about virtual reality and these advanced technologies which are there today. And it's also not about map ethics. I mean, there is no information about how to use different map. Yeah, there is something about map projections, but there is, of course, nowadays lots of attention for map ethics because of fake news, etc. But that's not discussed in the book. Next, please. Okay, now I will say next quite a few times after each other because this is an example of an interactive approach. So next, please. Next, 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 next. Okay, so here you can see that if you would have an interactive environment that you can explore it, you can click on a country, you will see the values of the country highlighted in other diagrams, and by this you can play around with your data. Next, please. Okay, and then we also created posters for each of the goals, and here you see a poster for the goal number 1, the end of poverty, and there's always the map. There is some annotations in the map which give you the highest and lowest value or very specific numbers which can be found. There's always an illustration and some explanatory text. Next, please. Okay, the design of the book was such because, again, we made it with a team, and the team was in New York, in Madison in the US, in Enschede in the Netherlands. And yeah, we only met, by the way, as an author team 2 weeks ago in Cape Town at the International Cartographic Conference. It's the first time that physically the authors were together. Okay, but to do so, we had a very strict layout with columns and what you can see here, so that everything adheres to a certain layout so that it has the same look and feel all over the book. Next, please. We set up a kind of style sheet so that if people made these maps, then, so if I made a map, I knew line width, I knew color schemes, etc. So to make sure that, again, everything has the same look and feel. Next, please. Next, please. These are just a few examples of pages so we can go through. Next, please. Next, please. And this is the glossary. So again, all kind of definitions. Next, please. I believe that the word next is more frequent than the rest of my talk, so okay. So what you see here is again, when everything was collected, that was collected in a carto lab in Madison, and those people you see the pictures of, we had some students working for us, and they would, again, if I would send a map, they would check it, if I had the right colors, the right line, size, thickness, etc. And they would go through the text, as you can see, and edit it, and then we had corrections. So we had a whole iterative process in creating this. Next, please. Okay, but before we started with the book, actually, the International Cartographic Association made some posters for each of the goals, as you can see here, and these posters were exhibited in the headquarters of the United Nations in New York. And yeah, that was my first experience with politics and maps, well, in practice. Because next, please. And again, next, sorry. Okay, because this is the trouble I got. Maps have boundaries. And countries do not always agree with each other on the boundaries. So at one point, the upper map, which you see on the right side of Morocco and the Western Sahara, okay, Morocco says, well, it's ours. And then when that was in the map, because we used an open data set, the natural earth boundaries, so, and it has it like this, then the ambassador of Algeria came to me and said, you have to take it off. I demand that all these posters are removed because it's incorrect. Okay, so then the people at the UN, they got very nervous because they are very sensitive to all kind of political statements. And even though the people I worked with were even ITC alumni, but they became nervous and they created this poster, this sticker, and it was put on every poster. Kind of disclaimer, and if you want trouble, go to Menoyan, because I was the president, I was there, and they would address me like this ambassador of Algeria did. Okay, so at one point we adapted the map to the middle one, and I was at one point invited to Morocco to give a talk, and they wanted an illustration of the abstract. I said, oh, I take the membership map of the ICA, but that one had the middle one, and then it was removed because they preferred the upper one. So nowadays when I travel, I prepare my boundary file. I first look, okay, which country? What's their preference? Let's adapt, because otherwise I get into a fight and you never win. So these type of issues you have. Okay, then I said to the UN, okay, but if you know about this trouble, why don't you give us the boundary file you use? Because then we cannot make a mistake. No, because if we give you the boundary file, we have a boundary file, but then we have made choices, because that boundary can be only at one place. And we don't want to make choices. Yeah, we make them internally, but not. Okay, long discussion. at the end, we got their boundary file as well, and we could work with it. But then they decided, if you would make maps, please don't make maps, let's say, of the Kashmir area or so. Just take another example to avoid sensitivity. Okay, so I learned a lot there. Next, please. Okay, so I already told you it's about open education, and that's why we made this resource available to all of you. Next, please. Okay, the goals again. Next, please. Okay, so in the story, I also talked a lot with all kind of colleagues all over the place to see, okay, how does it work in practice? How easily do you collect data? And if you, because the idea is that all countries by 2030 reach all the goals. And they have to provide data on all these targets. And then the indicators. So many countries say, okay, I have the indicator, tick box, done. But then one of my colleagues from Burkina Faso came to me. I know him again, ITC alumni. And then he said, okay, look at one example we created. So he said, look, there's goal 6, have enough water available, and at the end the indicator that the proportion of the population can use safe drinking water. And behind that last sentence there is a kind of formula which you could apply in a GIS, so that you have to be around 1 kilometer from a water source. Next, please. So my colleague said, that's easy. We have a map of a database of all the water points. That's all the dots here, so almost 50,000. We know how many people live in our country. So if I divide it, then I have 255. And the UN says you need less than 300. So with 255, we are safe. Tick box. But then he said, but then the statisticians, because the statisticians, they invent these rules. They forget about geography. Next, please. Here an example. So in the middle of the circle, there's the well. And their circle is let's say the buffer of 1 kilometer around the well. And the black dots are houses. So as you can see, all houses are within this buffer. So tick box, you would think. Next, please. Next, please. Yeah. Okay, and here you can see that, and maybe do the next one as well, because then it's easier to explain, I guess. Yeah. So if we look at the bottom illustration on the right, and there is a house near this number 287. That's a high point, but there's a house there. And that house should go to this Bisiga well. But as you can see, there is a river with swamp. So they will never go there because they cannot cross. So they have to go to the well north, which is more than 1 kilometer. So next, please. So it means if you analyze the topography, analyze the geography, then the statisticians did not include it. Yeah, they take a buffer of 1 kilometer, but they don't realize what it means if there is a natural phenomena where you cannot cross. So it's much more complex actually than the statisticians think. Next, please. Okay, so here are examples of the different characteristics of the indicators. So it can be absolute values, proportional, it can be an index, it can be a nominal value, and there are some map examples. Next, please. Okay, so then I would like to briefly explain something about the planning. This is a section from the book, and next, please. And similar to what we found, that every cartographer has a plan until they actually look at their data, because the data always gives you trouble. We have missing data, we have uncertain data, we have old data. You can imagine different scales. It's usually a mess. And that was the same with this database of the UN. Because what also happened is, because the book of course was not written in a weekend, it took 2 to 3 years, but in the early stages we took some data, and then later on we want to make the final map, and we looked into the database again, and then the data were gone, or they were changed. So that's this problem. Next, please. So also the UN has all kind of internal guidelines for how to publish maps, and that has to do with this political difficulties. So yeah, that was an issue. Next, please. I told you about these databases, all kind of issues. Next, please. And then they had two data sets available for us as boundary files. A very schematic one on the top and a detailed one, 1 to 25 million boundary files. And they have made this now also open source, despite the political issues. Next, please. And then another interesting issue is that the United Nations has, okay, we all work with countries, the member states, but then they also created all kind of regions. And these regions were originally created around 1950, 1960, and each of the regions included about the same number of people at that time. Of course, population growth has been tremendous, so many things have changed. But then we had to deal with all these different type of regions. Next, please. Next, please. I skip a few because my chairman is looking at his watch and I have no clue where I am. But okay, then we had the different map designs, just to show that you have many options for working with your data. Next, please. Okay, then our dilemmas. So I talked about the book. And next, please. So again, we have this circle, so we make all kinds of decisions. Every one of you who has made a map, they know, maybe they didn't do it systematically as you will see here, but we make many decisions. Next, please. You cannot read it, but you can imagine. Okay, so you have to know your audience. You have to know, the data types you have. You have to know, you probably have to clean your data. I mean, working on your data is probably most of the work. Then you have to transform it, that it's all uniform. Then you have to choose your symbols, your map projection, and then you show it to your audience, because you have an audience in mind. Then you find errors, so you have to redo them again. So it's a whole circle which might even go several times around. Next, please. So again, all kind of questions, all kind of decisions. Next, please. So I would like to give you one example. Here's the UN data on gender inequality. So it's an index between 0 and 1. 0, male and female are equal. 1, they are unequal. And I'm afraid often it means that the females are then in a disadvantage. Okay, next please. Then I did an exercise. I have been at several UN conferences and I did exercises with them and I said, okay, here's the map, that index, please make me a map. And of course there is not time to make a map, so I asked them, okay, draw the legend of the map you have in mind. Next please. So I collected all these examples of the people, all professionals in the room. Some came up with a legend like this. Next please. And others came with legends like this. And then I always told the people in the room, if you see your legend on screen, don't start making noise or raise your finger, because you might be wrong and then you feel embarrassed. Because all these legends you see now, they are completely wrong for an index mapping. So the earlier ones were right. So you try to teach them how to do by doing, so to say. Next, please. So again, let's make this map together. Next, please. So you could also start ordering your data. In this case, we go from the high number to the low number. And already that gives you a kind of perceptual view on your problem, on your data. Because now you start with the bad ones. I mean, I call them unequal, I call it bad. And then you start reading, we read from left to right. I know some others do it the other way around. But then you already get in a pessimistic mood. Oh, look, all these high bars, that's not good. If you do the other one, next one please. Here, starting to read from left to right, you start with the low ones and you say, hey, wow, it's not too bad. Oh yeah, there are a few high ones. So it really matters on how you present your data, on what is the mood setting with your audience. Next, please. So I created this map. That's one example. But you can do much more. Next, please. So here are other ones. So the left map in red, in dark red, the high index numbers, meaning it's bad. So this would be the map which you make to show, okay, we have to do something. We have to action because we have to improve the inequality. And that map is a warning. If you go to the very right map, it's green, dark green. If you read the legend, it's correct. I mean, dark green is the high index. It's wrong. But green in most cultures has the idea, it's good, safe. So why worry? So you can see by playing with these colors, you can influence your audience. And that can be bad and it can be good. It depends on what purpose you have in mind with your map. Next, please. And also, if you play with your classification and legend, you can also influence the pattern. Next, please. These are next, please. Very simple examples. If you have 2 classes or 5 or 6 classes, next, please, you have a completely different pattern. Next, please. And also the type of classification you choose can be different. And you probably all work with QGIS or ArcGIS. And probably most of you only take the default. You feed the data to the software, it makes a map. But the defaults are very often not the best solution. So you better think next time or ask your experts in the room. Next, please. Next, please. And next, please. Yeah, sorry, this word next, I cannot say it anymore later. Next, please. Okay, map projections, another example where things can become interesting. So this is an equal area projection, so then again you are able to compare sizes of countries. Next, please. Then of course you are next please, familiar with this projection, Mercator. It's terrible for this purpose. It was good for navigation, but bad for this. And yeah, many people use it simply because all these providers like Google and Apple and even OpenStreetMap, they come with the Mercator projection because longitude and latitude are rectangular, perpendicular to each other, so you can make these tiles, you can prepare them, and if the user is zooming or panning, it's quick. That's the only reason, but for many mapping options, it's completely wrong. Next, please. Next. Another example, this is a cartogram where the size of the area is in relation to the number of people living in the countries. And that again gives you a different view. And it might show you the magnitude of the problem far better than any of the other projections. So again, we have a beautiful toolbox as cartographers to create many different maps. Next, please. Sometimes there's another problem that these small maps, in this case, we have many what we call small island developing states, and if you present them on a map, where are they? They disappear because they're too small. Next, please. So we also worked on suggestions, change the map projection and amplify with special symbols those small island states so that they also are more prominent than, let's say, the larger countries. Next, please. And then again, if you make these maps, like this, what we call choroplate map of North America, people might get the impression, you won't because you are experts too, but you might get the impression that in Canada, the phenomena we look at is homogeneously distributed over the whole country. Now, probably, since you're all geographers, you are aware that, can you name one phenomena that is homogeneously distributed over our land? I don't think it exists. Next, please. Because here you can see it's about population, and the population of Canada is along the US border, and the rest is empty. But the map on the left gives you the impression that in the north it's the same as in the south. And it's not a problem if you're aware of it, but most people are not. And therefore they might get a different, wrong image of the problem. Next, please. Okay, then I'm almost there, Mr. Chairman, so no worries about time, I guess. Then, as map users, we also have some dilemma. Look at this map. This is one of the examples of the UN administrative divisions of the world. And this is about the percentage of forestry in the world. Next, please. So we look at this part of the world, Central Africa, or Middle Africa, as they call it. And then, okay, I always learned that in the north of Africa, there's the Sahara. So you see the northern part of this dark green region, that's the country Chad. And next, please. If you then zoom in to that region, then you can see that Chad has only 3% of forest. So actually, if you look at the country itself, it would be in the light yellow and not in the dark green. But again, because of the scale of the administrative units selected, this regional division, it's linked to a certain region, that again gives you a completely wrong impression of this phenomenon. Because, yeah, it now is dark green, but in fact it's only 3%. So that's not true what the map shows, so to say. And these things, I think it's important to inform the user about this, because many of them, especially if you send this to government officials or something like this, they are not trained as you are, so yeah, they might have difficulties. Next, please. So, can we help the map user? That I think, and that's an important thing. And because on the left you see this planning scheme again, where all these cartographic decisions are being made, and maybe we should inform the user about these decisions. So next, please. Next, please. So maybe we should tell the people about the data you see in the map. Next, please. Or we should tell them about the type of map we have used and what the pros and cons of such a representation are. Next, please. And maybe there's a story behind the map which can explain things. And maybe you can make annotations in the map that, again, this story becomes visible for the user. Next, please. But then again, today we all heard about UAI and GTP. So maybe there is a map GTP, and we don't need cartographers anymore. Well, today that's not yet possible. Next, please. Because what we would like to see, we would like to inform the user about what happens in this map creation process. So we would go for this transparency, and that's what they then call responsible AI. But is it there? And what are these large language models which are being used to do all this? What are they using? So next, please. So I think if they use my book, it will be okay. No, that's not necessarily the case, but this might be the future. And I guess this is a good moment to stop. Because I don't know the future, but it might go in this direction, and I'm looking forward to see when can we ask one of these map of GTP, asked it, okay, please make a map of Java using the administrative units like municipalities, and then create an employment map for 1950 or something like this. And then a few seconds later it's there. Well designed, according to all the rules, who knows? Next, please. Okay, so again, here is the URL of the book, and the organization has my presentation, so they can distribute it to you all. There's no problem with that, and then you can find it. But also, if you type the title in Google, you will be able to find it. Next, please. Oh yeah. They all created nice stamps of the Sustainable Development Goals, and since I'm collecting stamps and maps, this is the only one, I'm afraid, of the only stamp with a map on it from the SDGs. And next one. Thank you very much.
Well, thank you very much for Professor Manuyan. It was very nice presentation, and then it delivered a lot of important things to us related to the cartography and then perception of the reader of the map as well. And then it was very interesting with Map GPT as well, because nowadays we use a lot AI and artificial intelligence for everyday's work. So yeah. Now we are entering the question and answer session. Maybe you guys here, you have several questions, 1, 2, 3 questions maybe. Questions? Yeah, please. Could you please introduce yourself and then ask your question? Thank you.
Hello, my name is Yuni. I'm from Jakarta. Thank you for your presentation. It is very nice and very interesting. Actually, I'm quite new to the maps here, so I'm sorry if my question might be not really good question. So earlier you mentioned about the map users dilemma. So my question is, for example, if we have like 3 same map from the same place, I mean, but have different informations in each map, but I want to make it into one map, but in the end it ends up too many information. So is there any tips and trick on how to make the information in one map is just enough or sufficient? Thank you.
Thank you for your question. So you want to know if you have multiple variables, so to say, multiple topics which you want to integrate in a single map. Well, of course, first of all, it depends on the type of information and how well it relates. And it is, of course, possible to bring everything into a single map. It really requires, design skills, so to say, to do this. Still, the map could be too complex to read. And then sometimes it's just better to have 3 maps next to each other. And then you have to compare. But of course, when you are able to work online, if you click on one area, it will also highlight the same area with this other information in the other maps. So then it's easier to compare. And you could also ask all kinds of questions where maybe other visualizations pop up in diagrams where you can compare values, etc. So on the one hand, yes, it's a challenge for the cartographer to bring that in a single map. And it really depends on many factors again, like how many small units do you have, and also how is the distribution of your data, because one of the biggest dilemmas we always have is if you have, let's say, I'll take all the countries of the world, and you have the population. And of course, the smallest country has maybe 100,000 or even less people. And if you then go to India, which nowadays has the highest population, it's more than 1 billion. So if you have to make a symbol for 1 billion and for 100,000, and you want to see them all and everything in between, it's almost impossible. Okay, so and if you then have 3 of these topics, you can imagine that it will be a mess. And sometimes cartography can only result in a mess. But then the question is that bad? Well, maybe it is a mess out there. And then, it is complex. Okay, then there are many ways to let's say, normalize or harmonize it so that you can make it more simple. But if you make it simple, you lose some detail, of course. These are choices you have to make. And that also depends for whom are you making it. Do we really need the detail? Do you just want an overview? I mean, these type of questions you have to answer. But they are challenges, certainly. Thank you.
Well, thank you very much for answering the question. Any other question or questions? Yeah, please, Prof. Projo.
Good morning. Thank you very much for your nice presentation, Professor Krak. Basically, I'm a remote sensing scientist, so my knowledge about cartography is limited. According to what you have presented and also many examples used by cartographers, I found that many of them use socio-economic data instead of biophysical data. So what do you think about this phenomenon? Is it caused by that physical data is more difficult to be presented in terms of map, or there is no challenge in presenting biophysical aspect? This is my first question. And secondly, as you know, here we have remote sensing, GIS, and cartography. Okay, And if we look into these three sub-disciplines, remote sensing is closer to GIS as compared to cartography. But cartography is closer to GIS compared to remote sensing. So remote sensing is somewhere in the left, cartography is on the right side, and GIS is somewhere in between. What do you think about the aspects of remote sensing which can ignite or fuel or stimulate the development of cartography, or on the other side, what aspects of cartography can stimulate the development of remote sensing? Thank you very much.
Yeah, no, these are very interesting questions indeed. So the first about the, let's say, the social and the physical geography mapping, so to say. I mean, again, in the examples I've given now are more in this domain of the social geography, because, and that's mainly because of the nature of the data, because every country provides a number, and the country is the base unit for mapping. While in physical geography, if you make a geomorphological map, the landscape units are the basis for mapping. And in let's say, working with the socio-economic data and let's say these units, there are many alternative maps to create. So there are interesting challenges for a cartographer to think of these things. For the physical geography and geology mapping, then of course you have your units which are delineated by features in the terrain. And then for geology, for instance, they have international color schemes which have been agreed upon. So yeah, you just apply rules and there's your map. I mean, I know it's not exactly one-to-one, that simple. Of course, also you have all kind of different map types where interpolation between values which you measured in the field are being done. So again, then again, these maps follow the same rules as the other maps, only there are fewer types to play with, because yeah, the landscape decides on what happens, so to say. I hope that answers somehow your first question. And of course, because also the data from the physical geography in a way is we might get a fight now, is more limited, because you just have, let's say, your morphological landscapes type, and that's it. While with statistics, where people are involved, there are so many different aspects of society which are measured and stored, where you would like to visualize this, so that has a wider pond of data to tap from, which could be mapped. Okay, your second question about remote sensing, GIS and cartography. I think, cartography is certainly not only about these thematic maps, it's also about topography. But then again, the remote sensing visualizations, they are basically pixels. And these pixels get a color based on a value which has been measured or observed, so to say, by the sensor. That's often what happens. And they use a color scheme. And then again, what else can you do than this? Of course, you can aggregate, which happens. You can combine and you can make time series. But the pattern is always this pixel-based pattern. So that is, okay, here comes the second fight. It's terribly boring at one point for the cartographer. So again, you have not many alternatives. Yeah, of course, you can vectorize it and make polygons of it, and then you can start do other things. But basically, people use the pixels, and the pixels are also representing objects or something like this, which have been observed, so to say, or depending on all kind of constraints and models behind the pixel value, so to say. So, and also we can still improve a lot, because many of these remote sensing maps, they use the rainbow as a kind of color scale. Even if there's an ordered set, they use red, blue, and all these other colors, which is, we as a cartographer always say, hey, it's strange, because why would blue be more than red? Yeah, in radiation, physical numbers, yes, but not in perception. So again, there are all kind of interesting debates always among people who make the remote sensing maps and cartographers. And both, of course, we use GIS, and both are available as tools in GIS. And of course, you have all kind of overlays that you can map all kind of other phenomena on top of remote sensing imagery. I hope that somehow clarifies. At least my opinion then. I don't say this is the law.
Yeah, thank you very much for the second question. Last question, maybe? Yeah, please. You can introduce yourself and then ask your question.
Thank you very much, Professor Krak. My name is Jody. I'm for master student of remote sensing in this faculty. I actually amazed with your presentation today, this morning, and I have very high interest in cartography, that's why I study geography in here. So my question is, you have experience making many global maps, and how do you equalize the perception of colors in each country? Because maybe each country has its own meaning and perception of color. And how can you make a global map whose the symbolization can be accepted in each country, like the one in your book you have presented? Thank you very much.
Yes, again, I have only very good questions here today. That's nice. No, indeed, there are differences in color, on how people perceive color. So I use the example of red and green for danger and safety. That's partly related to if you go in the traffic lights also follow that scheme, and that happens more or less everywhere the same. But in some regions of the world, people are very fond of very bright colors, so to say, and in others they use very subdued colors. Yeah. So, is there a global solution? Probably not really, because you have to adapt it. But then the question is, if you adapt it, let's take Indonesia and the Netherlands. Let's assume that we have different perception of colors. And now you make your map, I make my map, same data. And now we have to communicate. I see you map, but I see something different than I see on my map, and the other way around. So we see different things, even though it's the same. So that probably would require a kind of agreement. Okay, let's use one color scheme, or today for this topic we decide on this color scheme. And I realized that because of the history of cartography and for instance geology, when they set up this color scheme, that was produced in Europe. So somehow the view from Europe is then, for all kind of reasons, spread over the world, but that's not necessarily the correct one, but it's the majority one at the moment. Like English is everywhere nowadays. We don't speak our own language here because, also as a kind of way to be able to communicate. And you could do similar things with the color schemes, yes. But it's typically clear that the meaning of colors, I mean, even this morning I was in the elevator and I was missing number 4. 4? We have sometimes might miss number 13. So again, different color, the cultures, different perspective. That's the same with maps. And it's good to be aware of these things, yes. So, thank you. I hope this helped a little.
Well, thank you very much. I think that is all for this the first speaker. I would like please give him a warm applause for Professor Manoyan. And then now we move to the next speaker, Dr. Yuichi Sakai. Are you still with us in Zoom meeting? Yuichi?
Oh, yes.
Yeah?
Oh,
Can you
can
hear
you hear
my voice clearly over there?
Oh, yes.
Okay.
Yes.
Yeah. Well, before starting this session for Dr. Yuichi Sakai, I would like to introduce to all of us Dr. Yuji Sakai. Yuji Sakai is an assistant professor of forest science at the School of Agriculture of Utsunomiya University, Japan. And his research focuses on numerical modeling of landslides and debris flows that take place in subaerial and submarine environment. And he is also interested in the application of the model of hazard mitigation. He's currently serving as editorial board, a member of Japan Society of Erosion Control Engineering. And Dr. Yuichi Sakai will deliver a presentation on numerical model for large-scale landslide based on digital elevation model. So please welcome Dr. Yuichi Sakai. You will have 30 up to 35 minutes of presentation, and then it will be followed by question and answer session. You may start your presentation and share your screen.
Okay, I'll share my screen. Maybe can you see my screen?
Yeah, clearly.
We look here, okay? Here's the presentation now.
Sorry, Yuichi, maybe you can minimize your screen.
Yeah. Oh, okay. I'll try. Okay.
You can share your screen like the first time. It was much better. Stop.
Okay.
You can stop the. Yeah, that one is better. Yeah.
Okay.
Okay.
Okay. Can I start my? Okay. Thank you, Sandy. Good morning, everyone. I just started my career last year, but it's really a great pleasure to be here. I'm Yuji Sakai from Utsunomiya University, Japan. Today, I'd like to talk about a numerical model for large-scale landslide based on this digital elevation models. My talk is a little bit specific, but yeah, I can move on to presentation. In my talk, first I'm going to explain what's landslide and how to prevent landslide disasters. Here I'll show the importance of creating hazard maps based on numerical simulation models. Next, I'm going to explain building numerical modeling of large-scale landslide. A large-scale landslide is shown right here. It takes place in Kagoshima Prefecture, a southern part of Japan in 1997. And so recently, large-scale landslide a big problem in Japan due to heavy rainfall, and it has a really large volume and high fluidity. To illustrate the high fluidity of the large-scale landslide, we conducted firm experiments of landslide and built new numerical simulation model for disaster mitigation of large-scale landslide. Then we applied the new model to a large-scale landslide event occurred in Japan to validate its reproducibility. Okay, first of all, I'll explain what landslide. As you can see on the left figure, landslides are mass movement of soil in steep mountainous regions. They are triggered by heavy rainfall or earthquakes. These triggering events induce steep surface in the hill slope, and then landslides move down like this. The fertilization of landslides leads to severe damage to human life and properties at mountainous areas. For example, Hiroshima Prefecture, Japan has steep mountainous areas and suffered a lot of landslides like this due to heavy rainfall in 2014, and 77 people were dead in this disaster. To prevent landslide disasters, it is important to predict where landslides occur and where can be suffered. There are several countermeasures, and it's important to take both structural and non-structural measures to mitigate the impact of landslide disasters. So for the structural measures, check dam is most fundamental countermeasures for landslide, and it is set near the occurrence place to stop landslide directly. For non-structural measures, we have early warning system or hazard maps. Early warning system for evacuation before landslide occurrence is also is based on rainfall monitoring like this. Here it shows the vertical axis shows the 1 hour precipitation, and the lateral axis corresponds to the accumulation of precipitation. So this line shows the rainfall event, and if its amount exceeds the critical line, it's decided based on the past landslide events. So we apply our warning system. So based on this, the timing when landslide occur is predicted. Also, hazard maps are important to prevent landslide hazard. Hazard map indicates the place where can be suffered by landslide, like this yellow line or yellow zone or a red zone. So construction of houses are restricted in this warning zone. Creating hazard maps are cost-effective compared to structural measures and easier to spread wider and earlier compared to other methods. So geographical information system, GIS, based analysis incorporating these elevation models, DEM, are effective tools for creating landslide hazard maps. Although traditional hazard maps are often constructed empirically based on topographical conditions, like this. This map is created by empirical relationships based on topographic condition, only topographic conditions. But recent developments have allowed for the creation of such maps using numerical simulation models. This map is based on the numerical simulation models. So these numerical simulation models can generate more precise hazard maps when applied to high resolution digital elevation models, DEMs, due to their fundamental foundation in physical roads. And some have been integrated with already with GIS softwares. The construction of these numerical simulation models necessitates a comprehensive understanding of landslide dynamics. Often these models use depth average equation of mass and momentum concentration, and landslide dynamics are captured through the resistance flow and entrainment rate equation, typically corresponding to the internal stresses of landslide. These internal stresses can include interparticle friction and collision of the particles like this, and the core fluid stresses such as viscosity and turbulence, and also particle fluid interaction. Landslide models often idealize these internal stresses, assuming that they consist of uniformly sized spherical particles. These models have been validated through room experiments and have successfully explained measured values such as velocity profiles. in the formation. So natural landslide inundation areas have been reproduced using landslide models that assume a uniform grain size and utilize a representative value for grain size distribution. However, large-scale landslides often extend to gentler slopes than those predicted by models. So recently, large-scale landslides have been triggered by extremely heavy rainfall due to climate change. They showed a large volume and long runout distances compared to normal landslides. This caused severe damage to human life and properties in wider range of the mountainous slope areas. So their high fluidity, long runout distance, was not explained by existing theory. So it was hard to manage disasters caused by large-scale landslide. So, and the long runout distance of large-scale landslide due to the existing research may arise from the suspension of fine grains within the landslide pocket. As you can see on the left diagram, in normal landslides, sediment particles move in contact with each other, so this leads to large friction, so low fluidity. In contrast, in large-scale landslide, here, some sediment particles are suspended, this brown one, due to strong turbulence caused by large-scale movement. So less particles are in contact with each other, and this reduces friction, leading to high fluidity. Factoring this effect into numerical models as an increase in apparent pocket density has improved their accuracy in predicting large-scale landslide runout distances. So therefore, it is important to know how much fine sediment is suspended under what conditions. Traditionally, grain suspended in the pocket had been estimated based solely on grain size. For example, given a grain size is decided, and under this grain size is all suspended during flowing of landslide. But conditions of sediment particles to be suspended are still not clear. So this is due to difficulty of measuring the amount of suspended sediment in the natural scale or experiment. So it is important to measure the amount of suspended sediment in flume experiments. So in the present study, we have two objectives. First is to elucidate the conditions under which particles are suspended by conducting flume experiments of landslides. And the second is to develop a new numerical simulation model for 2D planar flow for application in large-scale landslide hazard map. Yes, the first one, I'm going to talk about first one. To investigate the conditions for suspension of fine sediment, we conducted a lab experiment of landslide dynamics. This is already published in the paper. This experiment, we use this experimental facility with a length of 10 meters and 10 centimeters wide and 50 centimeters high. And the sediment materials is set upstream of the plume, and the landslide was triggered by spined water at the upstream end. So sediment materials of landslide consist of two grain sizes, coarse and fine. And the grain size of coarse particle is set constant as 2.9 millimeters, and we varied grain size of fine sediment from 1.3 to 0.1 millimeters, and also we varied mixing ratio of coarse and fine for 4:1 or 1:1. And in the analysis, this is important one. So ratio of suspended sediment is calculated by focusing on friction factors of landslide. So this is very important analysis, but I'll skip the detail of the analysis due to time limitations and move on to the results. So I'll show the result of the ratio of fine sediment suspended estimated by experiment. When the ratio of suspension alpha, this one is alpha is 0, is corresponding to 0% of fine sediment is suspended. So coarse sediment is in contact with each other, but in this case, so 0% of fine sediment is suspended. So fine sediment also contact with each other. In contrast, when alpha is 1, also our fine sediment is suspended. So the figure shows the ratio of suspension alpha corresponding for each experimental conditions. Left one corresponds to mixing ratio 4:1, and the right one is mixing ratio 1:1. And each plot corresponds grain size of fine sediment. So as you can see here, when the grain size of fine sediment is large, alpha takes a value close to 0. This means like this. Almost all fine sediment is contact with each other, and then the smaller the grain size, the greater the ratio of suspended sediment. But the alpha is not simply determined by particle size, but also depending on mixing ratio. It's implying its dependence on kinematic conditions. Later, I will explain later. So what factors determine the suspension of sediment? Here we'll consider the process of suspension in detail. This figure shows the large-scale landslide. So sediment particles settle in pore water due to gravity. Here, the settling velocity of particles corresponding to their particle size. The larger the particle size, the larger the velocity of settling, and the easier to say pour. So suspension of sediment requires turbulence strong enough to overcome particle settlements. So the turbulent velocity of the pour fluid, Vt, so we use this one, it increases with the depth of the landslide and also velocity of the landslide. So it's expected to be greater for larger scale landslide. Therefore, we consider this ratio Vt divided by Ws as an index of turbulence. So then we compare the result of the ratio of suspension using the index of turbulence Vt divided by Ws. So this figure shows the compiled result of the ratio of suspension using index of turbulence velocity divided by settling velocity. So vertical axis is the ratio of suspension, and the horizontal axis is index of turbulence. And the plot of The plots correspond to the grain size of fine sediment. And mixing ratio in each experiment correspond black one correspond to 1:1, and the white correspond to white part correspond to white one. So as you can see here, this shows a relatively good trend. That the greater the index of turbulence, the greater the ratio of suspension. So by considering turbulence velocity of the particle in addition to the settling velocity of the particles, we are able to identify determinants of the ratio of suspension. So based on these results, regression equation was constructed to determine the ratio of suspended segment alpha like this equation. So here I explain the main point of my talk. So based on the finding of the experiment, we built new numerical simulation model for large-scale landslide. It was based on existing model for landslides, but incorporated new effects, I mean suspension of fine segments. In the numerical simulation, physical parameters of landslide, such as flow height or velocity, are calculated in time and space based on DM like this movie. Topographic change due to erosion and deposition is also calculated in this model. And please note that the numerical simulation model described here is designed for flow after the landslide has been sufficiently fluidized, because the process from landslide initiation to fluidization are not fully understood right now. So they are beyond the scope of this model. So I mean, only flowing process is described in the model. Here I show the governing equations of the model. We conceptualized landslide as a single phase fluid comprising of a mixture of sediment and water. As illustrated in the figure, the equations governing the landslide are a set of equations for 2D flow, x and y, and depth is integrated in this equation. Thus, the mass and the mass conservation equation and reset for the sediment water mixture, and also sediment particles, and we set also momentum equation for sediment water mixture. And these equations takes into account the influence of fine-grained sediment suspended in the pocket. So the mass conservation equation are divided into those for coarse and fine-grained sediment. We assume that coarse-grained sediment constantly contribute to interparticle stresses. Whereas fine-grained sediment act as a liquid phase with a portion suspended in the pocket, as a reminder contributing to the solid phase in a manner similar to coarser-grained sediment. And the resistance law and the entrainment rate equation E must be determined as a closure model for the governing equation, as I'll explain in the next slide. For the resistance law, the following equations are employed. Proposed by Igashira in 1997. This one presupposes that the internal forces of landslide can be expressed as a linear sum of Coulomb friction term, and the inelastic particle collisions, and the turbulence of the pole fluid. So tau y corresponds to the Coulomb friction stresses, and Fb is the friction factor corresponding to the collision and the turbulence. And also, for the entrainment rate equation, we applied the equation proposed by Gashira et al. 2001. This one is based on the concept of equilibrium beds of theta E, which in turn is based on experimental findings that in landslide under steady uniform flow conditions, there is an equilibrium bed slope corresponding to the current sediment concentration. So erosion occurs when the current bed slope theta exceeds the equilibrium bed slope theta E, and deposition occurs when it is less. The equilibrium bed slope theta E is derived from the force balance between the gravitational driving force and frictional stresses at the bed, like this. And also, to determine the sediment concentration behaving as a solid phase CS and the porphyry density rho F and the representative grain size dr in the these equations, another model is required to express the ratio of fine grain sediment behaving as a liquid phase, as I explained in the next section. So to incorporate the effect of fine grain sediment suspended in the porphyry, a regression equation estimated by the experiment is introduced into governing equations. So originally, we have two grain sizes, and the coarse and the fine grain one. And in this model, we assume coarse grain sediment always behaving as a solid phase, but fine grain sediment, for the fine grain sediment, a part is behaving as solid phase, but remainder behave as liquid phase due to suspension. So this amount is estimated by this equation, regression equation rate of suspension. So the sediment concentration that behave as solid and liquid phase CS and CL is estimated like this. And the porphyry density rho F was calculated by this equation considering the suspension of fine sediment, and the representative grain size of sediment behaving as a solid phase is also calculated by this. In summary, a numerical estimation model of large-scale landslides that considers the effect of fine grain sediment suspended in the porphyry was developed here. So finally, the developed numerical estimation model was used to analyze a large-scale landslide that occurred following rainfall on July 28th, 2015, in the Fukaminati region of Taramizu, Kagoshima Prefecture, Japan. Is here. West is southwestern Japan part of Japan. It's near to the Sakurajima volcano. So this landslide occurrence here involved a total collapse sediment of 91,000 cubic meters. Then flowed runout distance is 1.1 kilometer from to the here, and of the with an average slope of 6.8 degrees. So although there were no human casualties, substantial damage occurred to the national road. Here is national road, and greatly impacting local livelihoods. Here I'm gonna show the movie of landslide. This is really variable because this movie captures from initiation to deposition. So landslide takes place here and flowing down in this river, Fukaminati River. So the flowing, you can see the flowing landslide here in the channel. Then they move to the downstream area near the National Road Bridge. It looks really muddy type of landslide, and sometimes they include large boulders here. So here is really low slope. It's the speed of landslide is relatively decreasing. Okay. So we applied the new numerical estimation model to this event. So before the numerical calculation, we set the data of the large-scale landslide. So here, LiDAR topography surveys conducted before and after the landslide. So it's provided 1 meter mesh DMs with high resolution DMs. And also, the grain size distribution of the landslide is important to calculation of the model. It was measured from the field materials like this. It contains grain size from 0.1 millimeters to more than 1,000 millimeters. So I'll explain the numerical conditions used to implement the model. To apply the model to a natural landslide with a continuous grain size distribution, segment particles were categorized as coarse grain and fine grain size like this. So we divided using 50% grain size to divide coarse grain size and fine grain size. And for the fine grain size distribution, so we use integration equation for ratio of suspension to determine how much fine sediment is suspended. And also for comparison of the estimation, calculations were also conducted using a model that doesn't account for the effect of suspended fine grain sediment. So I mean, it corresponds to conventional model without considering suspension of fine sediment. In this model, so alpha was consistently set to 0. And also governing equation was solved using a finite difference method, the leapfrog scheme with spatial grid of 5 meters and the time grid is 0.01 second after smoothing the 1 meter mesh linear to a 5 meter mesh. So, and the other parameters used in these calculations are listed in the table. So here I show the computed result of topographic changes by the model without and with considering the effect of fine grain sediment suspended in the pocket. Here is the area photo of the event. Occurrence is here and then flowing to the slope and flowing to the Caminante River, as you can see in the movie. And this one shows the measured topographic changes calculated by difference of DEMs before and after landslide. So landslide has, this one shows the elevation change. So red one corresponds to deposition of landslide and the blue one is erosion of the landslide. So landslide, a lot of material deposited around here and also here, confluence point to the Caminante River. Here show, and also we show the calculation result. Here is by the conventional model, I mean, without considering suspension of sediment. So it shows the significant deposition very close to the occurrence point. It's not shown in the actual deposition. And also, innovation area is smaller than observed. But conversely, here I show calculation by the new model. So here is the calculation by new model. So new model, the model that accounted for fine sediment suspension accurately reproduced the position point or around a baseline field. So this result demonstrates the importance of considering the effect of suspended fine sediments in accurately modeling in large-scale landslide. So the suspension of fine sediment increased apparent forefoot density, low F, so thereby reducing friction at the landslide base, which lead to smaller equilibrium depth slope for the same sediment concentration, so that expanding innovation area like this. Considering that the model parameters were not specifically tailored for this landslide event in this model, the proposed model could potentially be applicable to other landslide events if we have the DEM, high resolution DEM, and the grind side distributions. So it may be beneficial for creating other. Okay, here's the summary of my talk. A numerical simulation model was developed for large-scale landslide that considers the effect of fine-grained sediments suspended in forefoot. The model was applied to a large-scale landslide event with available high-resolution DNs before and after the event. The result indicated that the model accurately reproduced the inundation areas and topographic changes caused by the landslide. So therefore, the model may prove beneficial for creating hardened maps for large-scale landslide in conjunction with GIS software. Oh, that's all. Thank you. Oh, yeah. Mm. Yeah, yeah. Thank you, Sandy. So it's really important question. So for physical models, we need a lot of parameters to calculate the equations. So it's really sometimes really difficult for the unknown event. So yes, it's really so. I also wondering how to use this model to unknown landslide event or so there's few data after landslide. So maybe in that case, we need to use some assumption for the model. So in my model, it's most important data is topographic data. First one is DEM, and maybe DEM is normally we can we can obtain after landslide because some national government will survey after the landslide. And also the second important data is grain size distribution. This is also maybe relatively difficult to obtain compared to topographic data, but sometimes we can obtain grain size distribution by sampling materials after landslide event. So other parameters is normally we use general value. I mean, it's not a measured one. So I mean, sometimes estimated or used in the earlier literatures. So for example, so density of sediment or friction angle of sediment particles, because the sensitivity of this parameter is not so high, so we normally use the general values or estimated value. So maybe, of course, as you say, it's better to use measured value for every parameters. But yeah, maybe I think it depends on the sensitivity of parameters. So and yeah, depending on that, we need to decide what parameter to be measured in the landslide event. So in this point, I think it's important to conduct sensitivity analysis based on the numerical simulation. Okay, that's all.
Yeah, thank you very much for answering the question. That was very interesting how to measure the parameter when the landslide occurs. From other participants here, do you have any question? Yeah. Please.
Okay, thank you for the presentation, Mr. Professor Yuichi Sakai. Here is one question from me. Is actually, is there any consideration from the grain size of the because I think when we talk about the transportation of sediments, especially in the river, there are even though the velocities might be different, but when we talk about the river, sometimes the boulder might remain in the high altitude. But in the case of landslide, is there any consideration of different grain size in the different altitude? Thank you.
Oh, okay. Yeah, thank you for really interesting question. So your question is about so in landslide model.
Grain size
we
differentiation based on the altitude at the landslide location.
Sorry, landslide location. My understanding is.
The question was about the grain size distribution based on the altitude of the landslide event. In higher altitude, maybe in higher altitude, maybe it is dominated by coarse grain size or fine grain size based on your experience in Japan.
I see. It's really important point, but actually, in my case, the difference of sediment grain size distribution is not considered in this model. So traditionally, that so the grain size distribution is same all over the flowing points. I mean, from upstream end to downstream end, because yeah. So yeah, it's really important point, but so to yeah, in my case, only calculating conservation mass conservation equation for fine coarse and fine grain size, because it's if we consider the difference of grain size distribution, so we need the information for grain size distribution for all over the calculation points. It's really maybe so it's related to Sandy's question. So it's really difficult to measure all the grain size distribution before and after the landslide event. So, and normally this kind of landslide event, grain size distribution is coming from occurrence point of landslide. So mainly supplied by the mainly it corresponds to the grain size distribution of landslide itself at the occurrence point. So in this case, we assume the grain size distribution of landslide is almost constant for all over the calculation domain. Thank you.
Okay, well, thank you very much for answering the question. Any other question regarding to this presentation? No more questions?
Maybe question in the chat?
Yeah, I cannot access the Zoom. If there is any
okay.
question in the chat room. Is there any question in the chat room, Yuji?
Yeah.
Yeah, you
Yes.
can read the question and then answer the question.
So the question is, what is your thought on applying similar approach on different landform landscape? What would be the necessary parameters, input data, or the approach to work on different landform landscape? Okay. Yeah. It's really important point. So my answer is to apply this model to different landslide or landscape. So first important one data is DEMs, digital elevation models. I mean topographical data, and also so as I explained before, we need grain size distribution of that area, but also the physical parameters of sediment grain or water, like density of sediment, grain size distribution, or internal friction angle. Maybe, but these parameters are set to general value used in the traditional model. So in this point, so my model at least needs DEMs and grain size distribution. Thank you.
Okay, thank you very much, Yuichi, for answering the question. Last question, maybe, if you still have question. Otherwise, we can end this second plenary talk, and then we can give a warm applause to Dr. Yuji Sakai. Thank you very much for joining this plenary talk. And then we have a coffee break. We have coffee break for 10 minutes, and then we will back with the third presenter here from Dr. Ariel Blanco. I guess we can have the coffee break over there, right? Is that right? Am I right? Yeah. The coffee break is over there, and then we will be back here in 10 minutes. Thank you very much for your attention, and please enjoy the coffee break.
Okay, I think the idea of organizing the GSS, Geoinformation Science Symposium, started in 2009. At the time, I was the chairman of PUSPIX, and PUSPIX stands for the Center for Remote Sensing Education and Training of the Gajah Mada University. And I saw that in between 1990 up to 2000, there was only 3 times seminars on remote sensing. That's why I thought that we need to organize that kind of symposium to attract more people having research in remote sensing and also GIS and cartography. And I also thought that it must be carried out regularly, at least every 2 years or biannually. So that's why we started in 2009 and then 2011 and then 2013, 2015. And fortunately in 2016, the MAPIN is the Indonesian Society for Remote Sensing, asked us, PUSPIX and the MAPIN Commissariat of Yogyakarta to organize symposium at national level, but involving people from around the world. And this symposium is called ICOIS. ICOIS stands for the International Conference of the Indonesian Remote Sensing Society. It was held in 2016 and it was very successful. That's why after that we thought that we need to change the Geoinformation Science Symposium, which was carried out regularly in Bahasa Indonesia, to more international conference. That's why started in 2017 we changed the GSS into international conference. And in this occasion we already had this symposium for the 4th times. And the motivation behind this symposium is first, of course, we need to publish papers, quality papers from the participants, not only from the lecturers and our students at the Faculty of Geography, but also Gajah Mada University, and also from people working on remote sensing, GIS, and cartography from various institutions in Indonesia and also neighboring countries. I think that's all. Well, I hope that this GIS can be a routine agenda and can develop further to attract more people from around the world involving experts in remote sensing, GIS, and cartography, so that this symposium can be an important link of this series of seminars, series of conference on remote sensing and information science events of the world. And for the 3rd time, we already made contact with the SBIE, and we regularly publish the proceedings of this symposium through the SBIE. When we talk about sustainable planet, we cannot separate it from the geography as a discipline, because as we know, geography has a major concern with the sustainability. So geography can view the world by using spatial, ecological, and also regional complex approaches. That's why by using remote sensing and also GIS and even cartography, we can try to, what you call it, to reduce the appearance of the Earth's surface in such a way so that the appearance can be made easier to observe. So by using the geoinformation science as a spatial analytical tools, we can make a better contribution of geography to what you call it, to overcome problems for the more sustainable planet. Well, I remember that when the computer vision and image processing technologies were still rare in 1970s, remote sensing already started using this technology for analyzing images obtained from the space satellite, for example. That's why we can say that remote sensing is one of the leader in this field, even though actually it is supported by technology and computer vision. And we can look back to the year of the middle of 1980s, when expert system is not fully understood by many people. Geographic information system already adopted this technology to solve any problem related to the natural resource management, how to overlay many maps controlled by the knowledge formalized into computer-based rules in such a way so that a good decision support system can be made for land evaluation, for spatial planning, and even for predicting the future land cover and land use. And now we can see that many people talk about artificial intelligence. And actually, GIS already made this improvement of this technology in 1990s. So that's why I'm sure that GIS can play an important role in the future for developing and using artificial intelligence for solving many problems in the world, particularly the ones related to the spatial problem.
session. I hope you enjoy the coffee break. Now we have the third presenter from our colleagues from the Philippine Space Agency. Allow me to introduce Dr. Ariel Blanco by reading his exceptional CV. Dr. Ariel Blanco is Director of Space Information Infrastructure Bureau, Philippine Space Agency. He's also professor at the University of Philippines, and he did his PhD degree at Tokyo Institute of Technology. And Dr. Ariel Blanco will deliver his presentation of his work entitled "Strengthening the Space Data Value Chains for a Sustainable Future." Please welcome Dr. Ariel Blanco, and you will have 30 minutes, 35 minutes of presentation, and it will be followed by question and answer session.
Thank you very much. So once again, my name is Ariel C. Blanco. I'm from the Philippine Space Agency, specifically the Space Information Infrastructure Bureau, the bureau in charge of downstream applications and services that we provide to various organizations. And I'm also from the Department of Geodetic Engineering, University of the Philippines, Diliman. And the title of my presentation is Strengthening the Space Data Value Chain for a Sustainable Future. And this month of August, we celebrated our first Philippine Space Week with the theme in Tagalog or in Filipino, Yamang Kalawakan Tungo sa Unlad Kinabukasan. This means space wealth or space resources towards a sustainable or prosperous future. Next slide. So before I proceed, I would like to thank the organizers of this conference, the GSS 2023. So this is the outline of my presentation. I will briefly talk about the Philippine Space Agency and the space data value chain and some of the projects that we are undertaking in the Philippines, from which we can also maybe collaborate on. And last but not least, the plan of action that we are implementing. Next slide, please. So please watch this video. This should play with the sound. Just an overview of the journey of the Philippine Space Agency, because we are a very young agency, just I think 3 years. So the WATA 2 is still operational and still can capture images in any part of the world. Recently, we launched the Maya 5 and 6, the nanosatellite. And we will start building this 130 kilogram satellite, MULA, or the multispectral unit for land assessment, primarily for agricultural applications. So our bureau is doing a lot of things, as well as other divisions in the Philippine Space Agency, including the monitoring of the West Philippine Sea or the South China Sea. Some of these applications will be explained in more detail later. Okay, next slide, please. Okay, the Philippine Space Agency was created by virtue of this Republic Act 11363, signed on August 8, 2019. No? And currently we are actually celebrating our fourth anniversary. And next slide, please. The Philippine Space Agency is basically the primary agency in charge with policy, planning, and coordinating, implementing, and administrative entity of our executive branch to implement this Philippine space policy or different programs relating to the Philippine space applications, space science and technology applications. Next slide. So we benefited a lot from the Department of Science and Technology's programs, including those projects on the application side, the downstream side, as well as those on the creation or development of satellites and putting up of various infrastructure. So the core mission of the Philippine Space Agency is value creation. That means we would like to support the Philippine space ecosystem to create value from space, particularly in the downstream applications on the side, or in the case of our bureau, the Space Information Infrastructure Bureau. Next slide. And we work on these following key development areas. So very important, for example, is for this purpose of the conference, the hazard management and climate studies, as well as those relating to space education and awareness. But we also do a lot of international cooperation, signing memorandum of agreements with different space agencies, as well as monitoring, for example, those critical areas for our national security. And primarily, those in the red font, these are our key mandates for improving public access and resource sharing, transfer and diffusion of space technologies and know-how, as well as doing some development and utilization, promotion of the various applications of space science and technology. Next slide. So this is basically a compendium of different applications. So volume 1 talks about space data mobilization. So many of the applications are similar to what we have seen in the past presentations during this symposium. And you can access this publication from our website. So the title is Our Place in Space. And we can see some of these applications later on in much more detail. Next slide. So this is an example of the value of utilizing satellite imagery. So in the southern Philippines, particularly Misamis Oriental, so the use of satellite imagery together with ground observations or ground reports led to the mining bust or closure of illegal mining in that particular area. So the emphasis here is that we would like to promote or really sustain the utilization of satellite imagery and other space data, geospatial information, in order to act on them and result in benefits to our environment in this particular case. Next slide. So by looking at the space data value chain, we can examine where we are actually improving, where we are actually needing much more support. In the upstream space infrastructure, so we are first have access to various satellite imagery, and of course we are also developing and operating our own satellites together with even the Novasar. We have 10% stake. So the data also must be accessible in suitable form. So this means that we can access the data, we can in various processing levels, level 1, 2, and 3, and so on. And we should also have the infrastructure, ground infrastructure which serves as our ears on the ground in order to download those images, to upload commands to those satellites that we have access to. Many of our bureau's work focuses on the capacity to integrate and analyze the data. That means to turn our satellite imagery into useful products, particularly for monitoring the environment. But the bottleneck or the value of debt in this value chain is basically the impetus and resource to act on the data. If you have data and share it to other people, particularly, for example, in organizations like the local government units, and they do not have the capacity to use that information, then we lose actually, or we break this value chain, and we don't realize what we are actually aiming for, which is that socio-economic benefit and value must be realized. So that's the main goal and challenge for the Philippine Space Agency as well as other organizations utilizing space data. Next slide. So we are making available various data sets, including, of course, the open and free access. But we also have satellite images coming from sovereign satellites. Currently, we only have 2. One is developed, of course, Dubata 2, and the other one is we have a 10% stake is Novasar S-band radar. And during the disasters, we activate either the Sentinel Asia or the disaster charter, and we can receive many images from various space agencies and companies all over the world to process and create maps for, say, flood mapping and landslide mapping and so on. But of course, we need high-resolution satellite imagery, so we buy from commercial companies like Planet and Maxar, no? And usually we promote this through the local government units to our project called the Data Allocation and Operational Information Flow. They can request data, and later on there will be a system to facilitate such a request process. Next slide. In the Philippine Space Agency, in our view, we implement these data analytics technologies and operation services using space data or datos. Datos is our word for data. And here we can see that we are establishing our high-performance computing facility. We are promoting the use of data or distribution of data through the DALOY project or flow. And we have various application development sub-projects, particularly on BRRM, environment, resources, land cover, and agriculture. And we network with various groups in the Philippines. We are establishing actually the Philippines integrated network for space-enabled action towards sustainability. So we do a lot of capacity building on top of the data that we generate and then the distribution of the various data products from those satellite imagery. Next slide. So I will be showing some examples of products that we do depending on, say, the type of sub-project. So this one is more on disaster hazard and risk mapping. So this is very important for the Philippines as well as for, of course, for Indonesia. So this project, every time we have say typhoons or landslide or earthquake, then we activate this protocol for rapid assessment of damages, or even mapping the impacts of, say, flooding and so on. Next slide. So this is an example of flood mapping in the south, in Mindanao. So showing the before and after imagery. So this is just Landsat 9, but we can clearly see the extent of those flooding in that particular area. Next slide. So those areas are actually automatically generated. So most of the time, of course, we utilize the SAR data from various satellites, including Sentinel-1 and including the Novasar S-band satellite. And we extract those flooded areas and map them over time. But this is done based on a trigger. So if there are reports on the ground as well as from the news of widespread flooding, then we process those imagery and distribute them to various agencies through our National Disaster Risk Reduction Council. Next slide. So this is an example of extended application, extending it to flood impact mapping, looking at the croplands in particular area. So currently, we are also developing approaches to monitor our croplands at different stages to determine the vulnerability to floods and be able to determine the extent of damage, depending as well on, or considering the extent of floods and those kind of things. Next slide. We're also active in, say, delineating hazards such as landslides, whether it's brought about by strong rainfall, or by earthquake. No? So we have to keep up to date our exposure data sets, those houses and so on. So we can see different logos in this case because many of these applications are conducted in collaboration with the Department of Science and Technology, Advanced Science and Technology Institute. Next slide. So in the past, say, typhoon, we also examined the possibility of mapping damages, utilizing, in this case, SAR coherence before and after, using different images from Sentinel-1 or even other Sentinel or SAR data sets. Here we can see those red areas having those severe or extremely damaged areas compared with other areas which are colored in yellow. And we can see the correspondence with the points which were delineated by UNITAR, which is based in Bangkok. Next slide. So this is another example of those damage mapping from Sentinel-1 SAR based on coherence approach, no changes in the coherence. Next slide. We also examine the use of, say, optical imagery before and after. In this particular case, we developed the normalized difference spatial autocorrelation index to examine the change in homogeneity or the texture. Normally, of course, when you have damages in the roofs, you don't have change in materials, or sometimes there will be exposure of, say, some other materials like pavement or concrete or other metals. No? But essentially, what you are looking at is from a homogeneous, it will become more or less homogeneous, and this can be quantified by, say, local Moran's eye. Next slide. This is basically a run-through of the methodology, looking at the use of local spatial correlation for before and after imagery. Next slide. And this map shows the extent of damages. Those red areas are more damaged in structures, and the yellow areas are moderately damaged, and the green areas are less or the least damaged ones. This can also be used for mapping damages in natural environment like vegetation as well. But for this particular paper, we utilize it for mapping damages to infrastructure. Next slide. In the recent months, we spent maybe 2 to 3 months tracking or monitoring oil spill. No? There was a sunken vessel, and it took time for the government really to act on it to sieve out or to suction the oil in the ship, and it continued leaking. So this was monitored. So we activated the disaster charter for this. So we received many images from various agencies, including those from the U.S. and of course from Europe, as well as from the Taiwan Space Agency. So we can see here that those oil spill can be delineated quite easily from radar imagery, but they can also be mapped from optical imagery. There will be a paper that will be presented in Egypt looking at the calculation of volume based on the result of this mapping. So this type of images we distributed to various agencies, particularly the Department of Environment and Natural Resources, so that they can calculate the impact on the coastal marine environment, so the economic and ecosystem valuation. Next slide. Currently, we are also monitoring the progression of El Nino, utilizing the outputs coming from the program Saray, specifically the program called the Drought and Crop Assessment and Forecasting. So as you can see, there are also various logos here indicating the collaboration of various universities as well as government institutions in charge of monitoring agricultural sector. So in this case, you have this ratio, the SVTR, as well as the combined drought indices showing different levels of agricultural drought. Next slide. They are also forecasting the drought over the next, say, 5 or 6 months to show where potentially severe and moderate drought will happen. In this case, we can see yellow areas in the southern part of the Philippines, and that's where it is projected to have the highest impact of drought in the next few months. Currently in the Philippines, we are still a bit rainy because of the monsoon rains, as well as the super typhoon in the north and so on. But eventually, this type of maps will come to be very useful, starting maybe in December, where we expect the rains to cease. No? Next slide. And part of the datos is also the applications in the environment. No? So we have the sub-project called the operationalization of environmental and resource mapping applications. So this focuses on natural resources, air and water quality, and many other things, so including benthic habitat later on that we shall see. So this provides comprehensive information in support to sustainable decision-making, management, and conservation of these particular areas. Next slide. So this is an example of land cover mapping that we are trying to improve upon. So this utilizes harmonized Sentinel-1 and Landsat data, utilizing many various machine learning algorithms. No? So the goal of this is to have a better approach or better methodology such that we can apply this and have our land cover mapping every 1 year or every 1 to 2 years. No? Currently, our National Mapping Agency produces land cover maps only every 5 years. No? So there's really a clamor to develop or to have these data products for the entire country for every year or every 2 years. Next slide. We are also working with the Department of Environment and Natural Resources and monitoring what we call the NGP, or the National Greening Program. Here we utilize indices from optical and SAR imagery, including of course, NBVI, EVI, but we also we are looking at the radar forest vegetation index, the radar vegetation index, in order to fully assess the whether a particular site of those NGP program, the National Greening Program, is actually improving or not. So this is part of like the auditing and monitoring program by our government. Next slide. As presented by Dan, no? So we are also doing burned area mapping. Many parts of the Philippines, you have the slash and burn farming or kaingin. So we have to monitor those burn areas, no? Including, of course, the fire themselves. No? And we would like to know how these areas are like being frequented by those kaingin or slash and burn farming activities, as well as how these areas are recovering from such burning. Next slide. So we are also looking at various data products, including land surface temperature derived from, say, Sentinel, not Sentinel, but Landsat 8 and Landsat 9, but we can also use Sentinel 3 and MODIS, and we can extend this to create what we call the health risk or health risk due to exposure to, say, extreme temperatures or higher temperatures. No? So in this example, so we look at the hazard as the heat coming from the estimations from the land surface temperature. Of course, you might argue that it might not be correlated sometimes with the air surface temperature, but at the moment, that's what we currently use. We look at the distribution of population, including those people who are elderly, which are presumed to be more vulnerable to extreme heat or urban heat island effect. Next slide. And of course, we also do monitoring of air quality utilizing Sentinel 5P or 5, and we also collaborate with the Koreans, or South Korea, in monitoring air quality using their geostationary satellite cold gems. Next slide. So going to the coastal marine environment, so as similar to the work of Dr. Prama, so we're also doing benthic habitat mapping. No? And currently we are also negotiating or discussing with the Fish Right program with people from US universities in order to utilize some of their methodologies that they have developed. No? So this is an example of benthic habitat mapping in Boracay, which is a very well-known island for vacation. And we are trying to, as much as possible, make it as little as much as possible from, say, PlanetScope imagery. Next slide. We are also working on a Persian seagrass mapping. So this is based on utilization of ultra-high resolution imagery from drone imagery. So in specific size, and this will become more as we go on. We capture drone images with a resolution of around 5 centimeters, and then from there we we map the coverage of seagrasses, and the seagrass from that particular ultra-high resolution images are used as basis for the machine learning of Persian seagrass mapping from Sentinel-2 images. Next slide. And these are examples of those products or initial outputs. We have to mask out those deep areas and maybe those extremely turbid areas, but practically this is already good enough. No? But we can still continue to improve this, and the hope is from the different sites contributed by various groups, various universities, we can create a more robust model which is applicable for seagrass mapping percent-wise all over the country. Next slide. This is an example of the application of linear spectral mixing on Sentinel-2 to estimate percent cover change. So a work of our undergraduate student in the Department of Geodetic Engineering. So you can see that drones images were also captured. There are measurements of the spectral measurements using, I think, ocean optics. And these are basis for the linear spectral mixing, those signatures that we obtained from the field. The goal is to determine the change between 2016 and 2022. Next slide. And these are the outputs for, this one is for coral, I think. And next slide. And then the percentage cover for seagrass. Yeah. Next slide. We're also utilizing PRISMA, hyperspectral imagery, first particularly the visible near infrared band only, and utilizing the linear spectral mixing to estimate from hyperspectral and satellite imagery the percentage of seagrasses. Next slide, you have percentage of corals and percentage of seagrass cover. Okay. So there are a lot of processing that you need to undertake in order to, come to the application of the linear spectral mixing. You have to correct, of course, for the water column. And in this case, we utilize the simple radiative transfer model. Next slide. Yeah, this one is for corals. Next slide. And you have the sand cover now, the exposed sand particular. Next slide. We had a project before together with Sir Jomer on the water quality monitoring from space utilizing Sentinel-3. And I think for this part, we utilize the C2RCC. We can derive the TSM and chlorophyll A, and then we can do so for the composite for every, for each month, barring the cloud cover. And we can see the dynamics of, say, high turbidity waters, high chlorophyll waters, particularly in the northern part of the bay, as well as those coming from Pasig River in the western side. Next slide. So that's some description of the C2RCC model. So this is implemented in SNAP, so you can utilize it for various images, including Sentinel-2, 3, as well as VIRS, MODIS, and Landsat 8 and Landsat 9. It gives you a good idea or a good result, particularly in, of course, in coastal waters for case 2, wherein you cannot see the bottom. Next slide. We are also utilizing products or indices, simple indices like the normalized difference chlorophyll index. But this index is relative, so we would like to create or transform this index to a more quantitative formula, utilizing the outputs from our previous C2RCC modeling results. Here we see that we can fit a exponential equation, and then based on that equation and applying it in different imagery, different dates or months, then we can see a good fit of that model derived from C2RCC as well as the transformed normalized difference chlorophyll index. You can also do the same for the normalized difference turbidity index. And this is the work of Sir Jomer. So he analyzed the different layers coming from the C2RCC to examine the spatio-temporal clustering of various data sets and identify the hotspots and the emerging hotspots. So this is a tool basically available in the ArcGIS. Next slide shows the those for chlorophyll. So doing so, then we can look at areas which are worsening, maybe due to anthropogenic activities, most likely, and areas of needing more attention from our government agencies. Next slide. We also monitored or applied these similar techniques. So this was an earlier project. Sentinel-3, you can also calculate the optical water type, and it gives you different classes. You have to basically calibrate which of those classes are, what ranges do they correspond to in terms of turbidity, in terms of suspended particles, and also chlorophyll A. We also attempted to use Sentinel-3 in order to estimate not only chlorophyll A, but also differentiate chlorophyll A according to spectral classes of microalgae or phytoplankton, according to whether it's contributed by gluine, or green, or diatoms and cretophytes. This is very important because this particular lake is dominated by so many structures, and you do a lot of nutrient inputs, not only coming from the watershed, but through fish feeding, and it may result into certain shift in community of the phytoplankton, maybe to a more dangerous species. Next slide. And we also are utilizing some biooptical models to estimate in case 1 waters, the suspended particulate matter. No? So this is more difficult to estimate, and the water quality is more difficult to estimate in these waters because you have the intervening reflectance coming from the bottom substrate. So the only way, I think, in order to do this is to really use bioptical models such as Balmer or other more sophisticated models. Next slide. And you might be needing more, say, temporally frequent or higher resolution temporally of your data in terms of monitoring water quality. So we can also use Himawari 8 for big bodies of water. So we have basically applied machine learning with our C2RCC or even those layers obtained from WASI or watercolor simulator, and try to create a model from which we can estimate this particular water quality parameters from Himawari images every 10 minutes. So particularly useful in areas where you have rapidly changing water quality, maybe based on the circulation or wind-induced waves, those kind of things. No? This is being currently done also in Laguna Lake. No? Next slide. So this is for chlorophyll, so we can see the variation every 10 minutes. Next slide. In the coastal environment, again, so we are monitoring coastline changes, detecting them automatically from various satellite images. So this is a case of illegal reclamation in the one tourist island in the south. Next slide, please. The extracted shoreline can be analyzed using this SAS. Next slide. And then we can estimate or examine what the rate of this erosion or even accretion or changes in the coastline, so for any particular environment. Next slide. Now I have 30 minutes. So the focus is basically to sustain or to support the attainment of these SDGs, no, as mentioned by Professor Crack and many other researchers. No? Next slide. And we are doing so by examining the different challenges. No? In the Philippines, this is particularly true, maybe also in Indonesia, that geospatial data is still not being used sufficiently to improve people's lives. No? There are many reasons to this, including that maybe the capacity still needs to be improved. The access to high-resolution data, not only imagery, needs to be improved. Expertise must be further developed for operational applications, as well as data sharing and appropriate policies should be put in place. No? So these challenges, next slide, we are addressing by examining also this value chain as well. Next slide, please click. So it is possible that we are actually actively sharing our data sets, images, and data products that we get. Please click. Then you have the LGUs not able to fully utilize those data sets. No, so we have to really focus on the capacity building of those who are going to use our data products. Next, please. Doesn't load. So that is basically the scenario. Just click. And then some LGUs might be able to use it for decision making, policy formulation, or implementation of actions. No? But many LGUs in the Philippines, next slide, they are not able to do so. No? So changing or giving just the data will not change much if we are not focusing on improving the capacity of our say partners. Next slide. Yeah, next. So currently, based on our memorandum of agreement between Fields and DNR, so these are the things that we are focusing in tandem with them. No? So this is a work in progress, the National Greening Program progress monitoring, utilizing various, say, parameters or indicators. And then we will move to the National Resource Accounting Program. This year, we will be releasing or working on the National Mangrove Map for 2023. So currently, we have for 2000, 2010, and 2020. No? And that will also entail capacity building and enhancement and development of systems and tools that agency, the Department of Environment and Natural Resources, can use. So the aim is we develop the methodology, we train the agency, and then they can do it themselves. No? Then we move to another, say, problem, another, say, demand for data. Next slide. And we are starting to implement this. So this was launched in April, the National Copernicus Capacity Support Action Program for the Philippines. supporting the Philippines in terms of strengthening our resilience to natural disaster and climate change. So this is complemented by the DOST, PhilSA, and the European Space Agency. Next slide. We have selected 3 pilot projects. So that will focus on forest and land cover monitoring, benthic habitat monitoring, and also on ground deformation monitoring. In the Philippines, we will establish at the Philippine Space Agency the Copernicus Mirror Site. So this will start, I think, sometime in January next year. And then there will be a third component on capacity building, so scholarships as well as training and various capacity building programs. Next slide. As mentioned, we are working on to expand this network, the PhilSA Integrated Network for Space-Enabled Actions towards sustainability. We believe that the data should be acted upon, not maybe after X number of years, X number of months, but immediately. Whenever we notice some disturbances in the forest, we have to inform the local government units or any mandated agency for that matter, and then action should be taken. So this also entails a lot of capacity building efforts, introducing our agency, because our agency is not known because of its very young stage. No? So we will be moving around, we are moving around the Philippines and meeting a lot of people from different organizations. Next slide. And integrated in the sense that you can just click, please, that we can work with different institutions, just click, click, click. And then we can integrate our actions, we can support each other in terms of managing, for example, provinces, regions, cities, even water-based, watersheds, and so on. Yeah, next slide. Because now I'm 35 minutes. Okay, almost down to the next few slides. So next slide. And currently we are also implementing the FINAS, or the citizen science. So capturing or marrying the benefits that we can get from Earth observation as well as from citizen science. Next slide. The current approach now is that we are asking citizens to basically give us validation data sets. So you have the ground validation data being provided by volunteer groups or organizations through the ODK Collect or the Open Data Kit. Next slide. So the goal is basically to improve our data products, and in the return, there will be benefits to various groups as well. So those in red fonts are in the near future we are going to conduct to improve those, say, citizen science activities, incentivize them, provide training for them, and do partnerships with many other groups doing citizen science in the Philippines. Next slide. And this is currently the bigger picture. No? We are developing the PhilSpace Plus, or a system of systems enabling institutions and citizens to access and utilize space plus use spatial data information for various applications. Next slide. For this plan of action, we have identified these various action points, including knowing the landscape, knowing the needs of those different groups, improving the absorptive capacity of world geospatial information, undertaking more research and capacity building efforts, sustaining and establishing sustaining a network of networks. Feedback is very important because normally we distribute a lot of data, but if there are no feedbacks, then we will not be able to know how to improve our products. We have to also continuously build and maintain our infrastructure, particularly the high-performance computing facility. And this is quite important, the increased private sector capacity, because whenever we work in the government, on the academe, we usually tend to forget the role of the private sector, at least in the case of the Philippines. Okay, next slide. So that's the end of my talk. So thank you very much for listening, and you can follow us with the social media pages and email us. Thank you very much. Terima kasih.
Well, thank you very much, Dr. Ariel C. Blanco, for presenting your work and your institution. Now we are entering the question and answer session. Do you have here any question regarding to this presentation? Yeah, please, could you please introduce yourself and then ask your question? Thank you.
Well, thank you, Mr. Blanco, for your amazing presentation. My name is Ferry Febrian. I'm an undergraduate student from Cartography and Remote Sensing in UGM. So, I'm interested with your presentation about the marine and coastal mapping. Yeah. So you mentioned before that the integration between the drone and for benthic mapping. So if I use the drone for do a benthic mapping research, we know that the drone have high spatial resolution. So if I combine with the other acquisition data method, like a photo transect, with just the underwater camera and the GPS, and we do the integration between two of that for geotagging concept, we know that there is a differences between the resolution with the drone imagery and the integration between the camera and the GPS. So I assume that there will be a bias in the geometric concept, because maybe the drone have a high spatial resolution and the GPS may be like 3 until 5 meters accuracy. So it will make a bias on for each pixel. So is there any way to accommodate that problem? Thank you.
In that particular application, our goal is to obtain the seagrass cover from the high resolution drone imagery. So if you have even within, and then we are going to match it with or model it with the Sentinel-2 imagery, which is 10 meters. And roughly we can see that they are matching. Even though if you have GPS, for example, from the Phantom drone, the coordinates might be plus or minus a few meters. It will still fit within that particular area. But another problem maybe is what you are referring to is if you are going to compare it with the say the transect that is obtained by ecologists. So during that particular survey in Bolinao area, where we have the largest seagrass beds, so we have also to match the drone imagery with those obtained by the transects coming from the ecologists. They do the quadras, they do also some picture taking. And that kind of thing can also be matched, not only by using GPS, but doing some matching in terms of the photo taken by the ecologists as well as the photo taken by the drone. So there can be some automated matching or some comparison in order to fully ascertain the location of transects in relation to the drone imagery. But in our case, since we are utilizing it for Sentinel-2, then that particular accuracy of GPS, which is maybe plus or minus a few meters, is still acceptable. So yeah, thank you.
Okay, thank you very much for answering the question. Any other questions? Otherwise, I will ask a simple question, if you don't mind. Congratulations for launching the nano satellite of Philippines. And then, do you know how much does it cost to build nano satellites like that? And then, did you have any problem finding the sensor due to maybe? I think every institution would like to build a very high resolution sensor, and then most of the sensor is coming from China, and then maybe you have geopolitical issues between the two governments, just like maybe in Philippine government and Chinese government. Maybe Chinese government doesn't want to release a very high resolution sensor to Philippines or something like that. Do you have the same issue in the Philippines?
So far, we have not encountered such issue, but in the previous programs funded by the Department of Science and Technology, that is meant for, say, developing the microsatellite, developing the nanosatellites, and now the development of nanosatellites is delegated to the universities now, particularly the University of the Philippines. So they do the recently launched Maya 5 and 6 was developed by university students, master students, and maybe later on by high school students. And in that particular program, I think the Stamina for Space, Project Optical is focusing on the payload development. They were even able to develop payload that is hyperspectral camera. And that camera might be put on satellite bus later on. So the good thing is that we have a good resource of people, so particularly physicists working and engineers working on the development of such a payload. In the Philippine Space Agency, we are seeing that our next move maybe might be to develop a SAR image, a SAR satellite, and then later hyperspectral. So to complement those that we can access utilizing, for example, Copernicus or other satellite systems.
Okay, well, thank you. Any other question?
But the cost I'm not so familiar with.
Yeah. Okay.
So I work in the
Okay.
downstream.
Okay, yeah,
Downstream
no
side.
problem. And maybe next question: is it possible to use Philippine satellite to monitor Pinatubo volcano or Mayon volcano, or because we share in Indonesia and Philippines, we share the same characteristics on volcanoes, and then I know that Phil Falk do the great job on the volcanology in the Philippines, and then maybe we can use this satellite.
Yeah, those systems can also be used, maybe particularly Novasar. But Novasar doesn't have some interferometric capacity compared to, say, Sentinel-1. But Philippine Space Agency is discussing with different space agencies across the Southeast Asian region. In particular, I think there was meeting with GISDA in Thailand. And of course, we have open communication with LAPAN or BRIN, and also with MISA. Yeah. So those type of cooperation, maybe there will be a opportunity later for various ASEAN countries with satellites to collaborate and share data sets. For example, MULA is optical for imaging, using captures of individual images. But I think Thailand has video imaging capacity utilizing the same satellite system, so we can share data sets as well.
Okay, well, thank you. Any other questions related to this presentation? Well, no questions? Well, I guess that is all for this presentation. Please give him a warm applause for his great job in the Philippines. And then now this is the end of this plenary session. And then we have some souvenirs for our keynote speakers here. Please come here. We have here some souvenir for Professor Meno Jan Krak and then Dr. Ariel C. Blanco. Please stand up. We will give you the souvenir. Yang mana? Dua-duanya atau salah satu? Oh, okay. And then the photographer will take photos. Well, thank you very much. And this one as well. I think this is a batik traditional tissue for yeah. Yeah, like this one. You can wear tomorrow. Yeah. And for Dr. Ariel Blanco, thank you very much. Thank you very much. Yeah. Well, I guess this is the end of this this plenary session. Thank you very much for all of us for joining this plenary session. And then we still have parallel session right after this session. So I hope you can enjoy this symposium and see you later maybe. Well, thank you very much. Thank you, Yuichi from Japan, if you are still in the Zoom meeting.